Hi everyone, in my last few videos I started discussion on data structure series, and in my last few videos I have made a discussion on what is data structure, what is the classification of data structures. If you guys have not seen those videos, then I just recommend you guys to watch those videos as well. So before coming to today's topic, I just want to tell you guys that if you guys like this video or if you got some useful and valuable information from this video, then click on like button, share it with your friends, and don't forget to subscribe to this channel. And in this video, I'm going to discuss one of the important sorting technique, and that technique is quicksort. So quicksort, as I have said, is one of the sorting technique which works on the principle of divide and conquer. So what is divide and conquer? Let us try to discuss this concept first. Divide and conquer is one of the programming methodology which says if the problem statement is large and if it is difficult to make the solution for that problem in a single go, then it's better to divide that problem into different subproblems and then try to target those subproblems individually. If still you feel that it's difficult to make the solution for those separate subproblems, then again further divide those subproblems into even smaller subproblems until you find the solution. So this is what divide and conquer approach is. So I will try to explain you what is divide and conquer and how this divide and conquer approach used in quicksort technique with the help of this example. So here I have taken an example with 8 numbers. So in quicksort technique we will be considering any of the element as the pivot element. So in this example I will be considering the first element as the pivot element. Now according to the divide and conquer approach, I need to bring this pivot element into its sorted position, where all the elements on the left of this pivot element must be lesser than 15 and all the elements on the right side of it must be greater than 15. Okay, so now I have applied the quicksort technique, which I will be going to discuss once I explain this. So as you can see here, what I have done is I have tried to bring this pivot element into its sorted position. As you can see here, now 15 is present at this place, where all the elements on the left side of the pivot element are lesser than 15 and all the elements on the right side are greater than 15. So what I have done, I have divided the entire problem into 2 subproblems. Okay, so this is one subproblem, this is another subproblem. Now again you need to apply the same quicksort technique by using divide and conquer approach on the left subproblem. Okay, here also you need to assume one of the element as the pivot element and you need to bring that pivot element into its sorted position in such a manner that all the elements on the left side of the pivot must be lesser and all the elements on the right side must be greater than pivot element. Okay, so like this divide and conquer approach works in the case of quicksort technique. I hope you guys understood what is divide and conquer. Okay, so now I will be using the divide and conquer technique and apply it on this example, and I will show you how quicksort works, and later on we will see how we can write the program for this quicksort technique using this example. Now let us start our discussion. Okay, so as I have said that we need to first consider any of the element as the pivot element. So I will be considering the very first element as the pivot element. Okay, and I will mark this 0 position as I, and I will mark last element as J. Okay, so what we are trying to do is we are trying to find all the greater than pivot elements. If they are present on the left side, we are trying to bring them on the right side, and if there are lesser than pivot elements present on the right side, we will try to bring those lesser elements on the left side. So that is our approach. So now we are checking, is there any element greater than pivot element on the right side here? Okay, there is an element 20. 20 is not greater than 35. 62 is greater than 35. So I will increment and I will mark this I here. I will come to the other end. Here I will check, is there any element lesser than pivot element on the right side? Yes, J is lesser than pivot element. So what I will do, here you can see I value is 2 and j value is 8. As long as I value is lesser than j, that is 2 is lesser than 8, you need to make a swap between I and j. So you need to swap 62 with 15 here and j was here. Okay. Now again we need to perform the same thing. We need to check, is there any element on the right side of I which is greater than pivot element? Yes. 90 is greater than pivot element. Now I need to do the same thing on the right side. I need to check, is there any element on the left side of j which is lesser than pivot element? 80 is there, but 80 is not lesser. So 25 is there, which is lesser than pivot. So I will mark this as j. Now again you can see 3 is lesser than 6. So 25 will come in the place of 90 and 90 will come in the place of 25. This was our I and this was our j. Again we need to check, is there any element on the right side which is greater than pivot? Yes, 75 is there. So 75 is greater than, so I will mark that element as I. I will check, is there an element on the left side of j which is lesser than pivot? Yes, 22 is there. So I will mark this. So I will swap these two. 22 will come here and 75 will come here, pivot. Okay, so our I was here, j was here. Okay, now again we need to check. Yes, on the right side there is an element 75 which is greater than 35. So I will mark this as I, and on the left side of j there is an element 22 which is lesser than 35. So I will mark it as j. Now you can see I has crossed j or j has crossed I. So after crossing, now the value of I becomes more than the value of j. Okay, so now you can see I value is 5, j value is 4. When I value becomes greater than the value of j, at that time you don't have to swap the values of I and j. At this time you need to swap the values of j with the pivot. You need to bring this 22 in this place. So 22 will come here and 35 will come here. Now you can see after applying the divide and conquer approach, we have managed to bring the pivot element which we had assumed initially into its sorted position, where all the elements on the right side of it are greater than 35, all the elements on the left side are lesser than 35. So now we have divided this entire problem into two sub problems. You can see this is first sub problem, this is second sub problem. So we need to perform the same algorithm or the same approach. So this approach is called as partitioning. Okay, we are partitioning. After partitioning, we are bringing the pivot to its sorted position and we are getting two subarrays, left subarray and right subarray. Now we need to apply the same partition algorithm on the left sub problem. So we will consider this as the pivot and I will mark this as I and I will mark this as j. Okay, now you need to do the same thing. Okay, so is there an element on the right side which is greater than 22? Oh yes, here. This is not and here. Okay, I need to check, is there an element lesser than pivot? Yes. Now j comes here. So in this case also, since j has crossed I, now the value of I becomes greater than value of j. So in this case you need to replace the element which is pointed by j with the pivot. So 15 will come here and 22 will come here, 25 here, then 20 and then 35. Now you can see all the elements on the left side of 35 now completely sorted. Now we need to apply the same thing on the right side. We will mark this as I and this as j. I will check. I will assume this as pivot. Okay, so 90 is greater than pivot, so I will mark this as I, and 62 is lesser than pivot, so I will mark as j. Now since I is less than j, so we need to swap I with j. So 62 will come here and 90 will come here. Now this was 75. Now again this was our pivot, right? Okay. So I need to check. Yes, 75. Yes, this is greater. This. Okay. So now in this case I has crossed j. The value of I becomes greater than the value of j. So in this case you need to swap the element pointed by j with the pivot. Okay. So now here 62 will come and 75 comes here. Okay, so as you can see here, now all the elements are sorted and we have managed to get the sorted numbers. Okay, so that's all for this video, guys. I hope you guys have understood this concept, and if you guys like this video, click on like button, share it with your friends. Don't forget to subscribe to this channel, and if you guys have any questions, then let me know in the comment section. Thanks for watching.